Question 4. Before I begin, I'm just going to think, well, what is the gradient of these things? The gradient of this one here is just going to be 3, isn't it? Because it's just a straight line, gradient of 3. The gradient of this one here is going to be 2x plus 4, because you've probably done some differentiation now. But doing it formally from first principles, that the derivative is the limit as h tends to 0 of 3 lots of x plus h take away 2 minus 3 lots of x take away 2 all over x plus h minus x. Tidying that up, limit as h tends to 0. On the top here I've got 3 x's and 3 h's, minus 2, minus 3 x's and a plus 2 on the end there. On the bottom, of course, is just h like every other one of them. We're going limit as that h gets closer and closer to 0. On the top here, the 3x's both cancel out. We've got a 3h here, and those are just both cancelling out, 3h over h. The limit as h gets closer to 0 of cancelling those gives you just 3. Well, as h gets closer to 0, that doesn't affect this, does it? It's just 3. It's always going to be a 3. And so there's that first one completed. And we expected it to be 3, didn't we? For the other one, we've got f dashed of x equals, so we've got x plus h all squared plus 4 lots of x plus h minus x squared plus 4x all divided by h, and it's the limit as h tends to 0 of all of that. See, I knew I'd forget that at some stage. So the limit as h tends to 0 of, multiplying out this top bit, x squared plus 2xh plus h squared plus 4x plus 4h minus the x squared and minus the 4x, all divided by h. Lots of things cancelling out there. So we've got the limit. The x squareds are both cancelling out there and there. I've got the 2xh, I want that. I've got the h squared, I want that. I've got a 4x there. And I've got a minus 4x again, so that's actually going, 4x minus 4x. I've got a 4h there as well. That's all being divided by h. So the limit as h tends to 0 of, cancelling the h's, I've got 2x plus h plus 4. So as that gets closer and closer to 0, this bit will get closer and closer to 0, leaving us with the 2x plus 4. And that's what we hoped the answer would be.